background a little bit. So we're a team in the UK. We're sort of from the traditional games industry that have been building fully on-chain games for the last 3 years. We started by building a game called The Crypt, which was a game that ran on Ethereum and used the Loot NFT. And then more recently, we've released a sort of pre-alpha version of a game called Downstream. Downstream is like a primitive autonomous world, I suppose. And I think people know what autonomous world is, but here's a video we took from the game. It's a shared world that lives on a blockchain that is permissionally composable. So all of these buildings that you see have been put down by people, and the functionality of those buildings, like what they do, has been defined by the people that deployed the smart contract. Anyway, I think you probably know that. That was Downstream that we released in May. I'd say the short version is nobody cared. And by that, I mean relatively nobody cared. So I think we probably had 1,000 people that stopped by. Some of them played the game. Some of them just said, oh, it looks like there's an NFT I could mint. So just minted an NFT. And by that, I mean relatively. So the things that I've done before were, the previous company that I worked at, we had 300 million downloads. On the company before, we had games that did about $500 million in revenue. And I'm not putting these up as a brag, because in some ways, these are rookie numbers. The Talking Tom, I think, has had like maybe 15 billion downloads. So, 300 million is small in comparison. I put this up here to say that, we haven't got anywhere yet in terms of reaching an audience, and I'm not happy about it. My ambition is beyond 1,000 people, is beyond 10,000 people, is beyond 1 million. And sort of when we shipped that version of Downstream, we sort of came together at an offsite afterwards. This is the Playmint team. And we said, well, how's anybody other than 1,000 people going to care about what we're doing? What do we need to address? And one of the things we highlighted was the fact that this is the way the game sort of plays. It's sort of like a board game, and each one of these is a transaction. So you could say they're hopping around quite quickly, given that each one of these is an on-chain transaction. But also, if you're used to playing Fortnite and Minecraft, this sucks. This is really bad. This is a bad experience. And we asked ourselves, I wonder if we could do something that is still decentralized, but doesn't go this slowly. So, this is running on, I guess this is Redstone with like a 2-second block time. And we did some hacks to speed it up, but nonetheless kind of slow compared with the traditional video game. Anyway, one of the engineers said, oh, I can solve this problem for you, but you might not like my answer, my solution for this. And I said, oh, okay, you're going to introduce some centralization to speed it up. Yeah, we don't really want to do that. He said, no, this is more decentralized than anything we're doing already. It just doesn't use a public blockchain. And I think you probably know how a fully on-chain game works, and I'm not the most technical person here, but here's my description of it. If a blockchain is here, a set of nodes that operate as a blockchain, and here's a set of players on the other side, and they connect to the blockchain. So these players give their inputs to the blockchain figures out what the new game state is and sends it back again. That's how... in a way, it's a client-server architecture. It's just that the server is a kind of blockchain with some weird attributes. So that's how all fully on-chain games work. But of course, between it adds a lot of latency. Like this is the 2-second block time is coming from these nodes trying to create consensus and then sending it back. And it also introduced gas costs as well. So it costs money to run the game. So the proposed solution was, well, why don't we just make the players the nodes? So all the players are already sitting on a computer that could be a node. Why don't we just make a blockchain from the people playing the game, not use any third-party blockchain at all? And so that's something that we call player chains. The players are the chain. That's how that works. And then, this talks about a 5-player game. Each one of these nodes, each one of these players is its own blockchain. And so you can connect multiple player chains to create a sort of lattice. So forgive my diagram, but you can build like a layer 1 blockchain where players meet other players and form a world consensus. So it's a type of blockchain, but it's different from any kind of blockchain that we've used to date. It's not a public blockchain. It's a bunch of private groups that connect to each other and form a global consensus. So that's how that works. But I mean, talk is cheap. And we said, well, what game could we build that really stress test this? What's like the worst test that we could give to make sure the player chains work? So can we build this, and can we really stress test it? So this is the game that we build. It's kind of a space shooter game, you can see. So, I mean, I'm not promoting this as some amazing new game for you to play. I'm saying, look, this is running a lot quicker than you would expect from a regular blockchain. That's what I mean. And what's going on here is each one of these columns is a player, and they have their own chain. And when they connect up with others, they form a block lace, which is what's happening here on the side. And it's the block lace is the kind of DAG consensus. So there's a consensus system connecting these players up. And it's a type of blockchain where it's sharing the inputs of each player in a deterministic environment. And, you know, the short version is that it's a different kind of consensus system that just runs a lot more quickly and a lot less expensive than running on a public blockchain. I think it solves some issues we've seen in a different way. So here, you know, some of these are a little bit spicy, but, you know, see what you think. Tell me afterwards. Here's an issue we found when building downstream. The first is that the games are unresponsive. You know, that 2-second hop around the map, which was limited to block time. How we solved it in downstream is we had a sort of hack that we called multiplayer optimistic updates. We're trying to anticipate what's going to happen on the blockchain. But it is a hack, and there are some side effects to that hack. Another solution that you see people using is app-specific chains and sort of customize app-specific chains. But my challenge is that you're really starting to introduce some centralization now. You've got like a single point of failure. I mean, we were running an app-specific chain when we were running downstream at one point, and it looked a lot like a server. It was an instance of Azure, and we were paying the Azure bill. So, you know, some of the decentralization has just fallen by the wayside in order to get things that are more responsive. A player chain solution is there's just a real-time consensus. The demo that I just showed, we locked to 100 milliseconds, but it's really down to whatever your network latency is. We're down that low at that point. Another issue we saw was transaction fees, you know, gas fees, and our solution, which you've got to figure out a way for players to be comfortable paying. Our solution for downstream was we paid them, but that's introducing centralization again. It's not sustainable. Somebody could hack it and break it if they did that. So while it's a sort of temporary solution and a lot of people use that right now, I think there's some downsides to doing that. Another thing that people are doing is, of course, provable off-chain compute, where taking the inputs from a blockchain, proving it, running the calculation somewhere else and proving it. So I think that's good, an interesting solution. That's something we've done ourselves. It still costs money to run those ZK proofs, and it's introducing some time to build the proofs and verify the proofs, and you're sort of introducing a new set of infrastructure when I think there's a different way that you can do it with the play chain idea. On-chain programming is hard. So Solidity is that we were using is not a bad language, but the EVM ecosystem is just weird. It's a very weird computer. You've got no update loops. All the things that I'm used to building video games with, like hidden information and random numbers and update loops and all these, you don't get those. And so any devs here will know that trying to build things for blockchains is weird and hard. For our game downstream, there was a user interface where you could really easily build something and deploy it to the chain where you didn't need any code, but you could only deploy the things that we had imagined you might want to do, and beyond that, you were back in Solidity again. So it was kind of limiting. Of course, there's a bunch of frameworks like Mud and Dojo. Awesome, glad they're there. But you're still coding. And you're still working with EVM. It solves some problems, but some remain. With player chains, it's really just sending inputs from one player to another. So you can use any language that you want. So if you're used to building things with C# and Unity or whatever, Unreal Engine, then player chains will work without you having to imagine a new system that's going to work on Ethereum system. And finally, spicy takes maybe public blockchains attract speculation. And I've been fighting against this for a while, but I can't deny it. Our solution for downstream was there's zero signaling. You don't make money from playing downstream. That was our solution. It's a game that's a different kind of game that you wouldn't have seen before. It's a primitive autonomous world. No one came. I mean, relatively, 1,000 people came. So I think there's a challenge there that, and some of the people that did come were just still hoping to make a bit of money from playing the game. So I think there's a challenge there with blockchains that the audience is very much people hoping to make money from your game. Other solutions is, well, just lean into it, making a game that's heavily financialized. That is a good solution. I would say that market is small, or certainly smaller. I think there's some selection bias in this room because there's probably more degens than there are in other places in the world. I would argue that most people don't want to play a game where they're having to spend money to basically bet on the outcome. So it is a market. I'm just saying it's not the largest market. On player change, you're just playing for fun. All right. In the last 6 months, two uncomfortable truths that I've had to face up to. I would love to be proved wrong on either one of these, please, but here's how I see it. The first is that public blockchains are the wrong choice for most decentralized games. If you want to decentralize a game and that's what you care about, trying to avoid any third-party control and not have a server and just have it genuinely decentralized, then a public blockchain is probably not the right piece of technology, not the right architecture to get that done. It's slow and it attracts a bunch of speculators. And I think there's different ways of doing it. If there was no other way of doing it, I go crack on. But I think there are different approaches that you can take. And that's what we've done with player chains. Second thing is financialization of fully on-chain games seems inevitable. And I hate this fact. This saddens me that why would a piece of technology seem to always lead to financialization? Who cares what it's built with? It's just a piece of technology. Why would people just expect to try and make money from these games? But that seems to be the reality. Other teams have tried to build things that are just a new kind of game that don't have any financialization, and it fails to find a market. So I've fought against this point for 3 years, but I'm ready to admit that this seems to be the case. So, maybe a challenge of building fully on-chain games is you can't get away from, culturally, you don't seem to be able to get away from speculators and degens and that kind of audience. And maybe that's okay if you build that kind of game, but if you're not, then maybe that's a problem. All right. So I would say, sort of in summary, if you're building a sort of slower paced game, like a strategy game or turn-based game, with a heavy economic layer where you're leaning into that finalization, just crack on. Perfect, probably the right choice. I would say that if you're not, then just stop for a minute and figure out, just consider your life choices. Anyway. Play the game that you saw, this little space shooter, which is really just a proof of concept, but equally it works. And disappointingly, it's way more playable than most decentralized games. We should be doing better. Anyway, the point is that it's fully playable. Source code's all available. Why we did it, how we did it, all of that stuff. What we put this out there for is to prove that there's different ways of approaching decentralization, and the one that you're using now might be the wrong one. That was it. Thank you very much.